Let's look at the internal structure of stars. What you see here is a drawing of the internal structure of the sun. You have the region here inside the sun in the core where the energy is being produced, then what we call the radiative zone, and then the convective zone. Question is, how do we know this? Well, we know this from models. We don't have observations of the interior of the sun, at least not throughout the whole interior. This is a typical solar model. As you see here, you have the density, the mass, the luminosity, the temperature, the nuclear reaction rate, and the pressure as a function of the radius. 1 would be the surface, and then 0 would be the core. The structure of stars of different mass is slightly different. For the sun, you have a radiative zone in the core and a convective zone near the surface. For a hotter star, you'd have the opposite. You have a convective core and a radiative envelope. For a star much less mass than the sun, you don't have any radiative zone, you only have a convective zone. And this is a model of the star Betelgeuse. Even though it's much more massive than the sun, it is also a fully convective star that has a structure similar to M dwarfs. This is the internal structure of a white dwarf star. You have a core that is mostly isothermal. You have a region of temperature change, and then the very thin atmosphere, that's what we see. Here you have the relative temperature and the relative density in green of a white dwarf. So again, how do we know this? We know this through our models of stellar structure. So let's study them now in this section.